Spotty gotta do?
Hey guys, let's talk about section 3.4, which is direct variation. And before we start talking about it, we're going to start with a little scenario. So we're going to say that you and a group of friends are in the car and you're going to go somewhere, I don't know, go play basketball, go play soccer, go on a hike, go do something, and you want to stop at 7-Eleven and you're going to get some Gatorade for everybody for your trip. And Gatorade this week at 7-Eleven, it's on sale. They're going to give you one of the big Gatorades for just $2. And so we're going to try and figure out how much it would cost for you to buy Gatorade for you and your friends. So, if your friends bail on you, and it was just you going by yourself, it would be just $2, and you're only buying one Gatorade, so the total cost is going to be $2. And for the purposes of this discussion, we're going to ignore tax, alright? But let's say you had your best friend, and they're not going to bail on you ever, so they're going to come with you. So now it's just the two of you. So you're buying two Gatorades, and the total cost of your Gatorade would be $4, alright? But if you were doing something really cool, maybe you had a whole car full of people. So now let's say there's 5 of you. All right. Now your Gatorade is going to cost you $10. All right. What if your little brother and his friends wanted to tag along, and now we got like 2 cars full of people. So now we have 10 of you, and the Gatorade is going to cost $20. All right. This scenario here is an example of direct variation. The total cost for your Gatorade is based on how many people are coming with you. Alright, so as the number of people going on the trip goes up, the cost of your Gatorade, the total cost that you're going to pay for Gatorade goes up. Alright, and it's going to go up by $2 for every person because that's how much one Gatorade costs. Alright, so this is an example of direct variation. The total cost varies directly, alright, with the number of people that are going. And if we were going to write an equation for this scenario, alright, to find the total cost, so we'll call this C, total cost, alright, so the total cost would be equal to $2 times however many people you have going, so we'll call this P. Alright, so total cost is equal to 2 times the number of people going with you. So the number of Gatorades you're buying. Alright, so this right here is a direct variation equation. And we used C and P because we were talking about cost and people, but in general terms, what you're going to see is a direct variation equation looks like this. Y equals K times X, where K is what we call the constant of variation. So I can change the number of people that are going, and that will change the cost, but the price of one Gatorade is still always $2. So 2 in this case would be K, the constant of variation. What is my total amount, or Y, going to change by every time that I change X? So let's look at some of these graphing examples. Here we have Y equals 3X. Alright, and they want a table, so I'm going to pick, remember we always want 0 in the middle of our table, and since this is a real tiny table, I'm going to pick numbers on either side, so -1 and 1. So if I were to plug -1 in here, 3 times -1 would give me -3. 3 times 0 would be 0, and 3 times 1 would be 3. So now I have points I can graph, so -1, -3, 0, 0, and 1, 3. Alright, and there's my graph of that line. And now I'm asked to identify some things. So the constant of variation, the slope, and the y-intercept. Alright, here's the equation we're using, y equals 3x, that's what we graphed. And the direct variation equation, remember, is y equals kx, and k is the constant of variation. So in this case, the constant of variation is going to be the number that's being multiplied by x, so it's 3. Alright, it's now slope. Remember, slope-intercept form, which we just learned, is y equals mx plus b. Alright, so slope is also the number that is being multiplied by x. Alright, so slope and constant of variation are the same thing. All right, if we have a direct variation equation, the constant of variation is the slope. They're always the same. All right, then we need the y-intercept. So I'm going to look at the graph. Where does this line cross the y-axis? It's right there. All right, and remember the y-intercept is a point, so it's 0, 0. For every single direct variation equation, the y-intercept will always be 0, 0. If the y-intercept is not 0, 0, it's not direct variation. All right, because look at this equation, y equals 3x, all right? And if we're talking about slope-intercept form, it's mx plus b, but there's nothing here, all right? And if it's not written, what's the only number that I could add to these and it wouldn't change the value? The only number that I could add is 0. So the y-intercept b is always 0 when we're talking about direct variation. So you've got a couple more examples there on the bottom of this page. What I want you to do is pause here, try numbers 2 and 3, and then you're going to come back and I'll have answers for you to check. Okay, here's the answer for the first one. Again, fill in the table, draw the graph. Constant of variation and slope are the same thing, whatever is being multiplied by x. Y-intercept is 0, 0. Here's the third example. All right, I picked a negative 2 and 2. Remember, if you have a fraction, you want to pick numbers divisible by the bottom so that you get nice even numbers for your y's. All right, constant variation, slope, y-intercept. You're going to pause here again. On the next page, you have 4 examples I want you to do, and then we'll check them in class. So go ahead and pause now and do those 4 examples. Alright, so we've done graphing, we've identified constant of variation and slope. Now we're going to look at the other type of direct variation problem, which is where they give you examples and ask you to write the equation. So write a direct variation equation that relates x and y. And they said, suppose y varies directly as x. Well, all of that means is the equation that we've been talking about. So y equals kx, that's the direction that, or the equation that says y varies directly as x. So don't get confused by that language. Alright. And y is 72 when x equals 8. Alright, and in order to write this equation, I need to figure out what k is. So k is my missing piece. But I know that if y is 72, alright, then x has to be 8. So now I need to solve this equation for k so that I can figure out what k is and be able to write my equation. Alright, I have k times 8. Alright, so to get k by itself I have to do the opposite, which is divide by 8. Alright, 72 divided by 8 would give me 9. So k is equal to 9. Now, this is not my final answer because the question asked me to write an equation. So the equation is y equals kx, but I know that k is 9. So y equals 9x. That's my direct variation equation. Now we're going to use that equation that we just wrote to find x when y is 63. So I have y equals 9x, that's my equation. They're telling me that y is 63 and they want me to find x. Well, this should be a simple equation for all of us to solve. I'm going to divide both sides by 9 and 7 equals x. Alright, let's do another example. Alright, suppose y varies directly as x. Again, that's my basic direct variation equation, y equals kx. And y equals 98 when x equals 14. So again, I'm going to plug these in first to find k, because right now I don't know what k is. So y is 98, don't know what k is, x is 14. Alright, so k times 14, I have to do the opposite and divide. 98 divided by 14 would be 7, so k is 7. So my new equation is y equals 7x, and then find y when x equals negative 4. So y, I don't know, is equal to 7 times negative 4. 7 times negative 4 would be negative 28. Alright? The rest of the examples I'm going to leave up to you, so you need to finish those, and then also make sure you're doing the little summary thing at the end. Remember, we talked about writing with math vocabulary, so make sure you're using good vocabulary, not just talking about the thing and the flip it and the do that. Use the words that we've learned. Alright, see you guys in class.